The future is well within reach indeed, but the future is truly bright when it's inclusive and takes everyone forward. Humanity faces many challenges that we can fight and win as one with the power of AI. That would be good, isn't it? I now invite Dr. Manish Gupta, the Director of Google Research India, to take us through how AI can help solve the world's biggest challenges in his session, AI for Social Good.
Okay, thank you for the warm welcome. I'll be talking about our work on AI for social good at Google Research India. So today I'll cover three broad themes. One is democratizing access to information in the local language for people. Talk about applying AI to healthcare related problems, and then also wildlife conservation. So let's start with looking at, again, how the information access can be democratized. So India now has the second largest pool of internet users in the world, and most of them are accessing the internet through these low-cost smartphones. And in many cases, these are the only mobile device that people are using. And they prefer to access information in their native language, preferably through voice. And if you look at a country like India, we have a rich diversity of languages. Only about 10% of the population actually speaks English. So as we look at providing information that you and I take for granted, right, which is easily available to us at our fingertips, as we try to provide this information to people in their local language, there are a number of different problems that we have to deal with. So let's start with looking at a few of them. One is this, even when people are typing queries in English or asking questions in English, often there are these variations in how they might type a particular word. So I've illustrated that in, for instance, this menu card from a restaurant, which lists the appetizer menu, and look at how the word appetizer or the word something like pineapple has been written. This is not how any native English speaker would write these words. But when you think about kind of the way people are thinking about it, right? First, imagining that word in Hindi, and then transcribing it back into English, into the Roman script. This way of spelling, let's say these words, actually does make a certain amount of sense, because phonetically, it is very close to how you might think of the original word, pineapple. And likewise, we see such variations also in Google search. When somebody searches for boys and then followed by SHUJ, ideally, we should understand that what they mean is they're looking for boys' shoes. So the way to understand this, all of these, make our systems robust to all of these variations, our team recognized that it was important to model the reason behind these different occurrences, that they made a lot of phonetic sense. And also there are changes in how people may pronounce things or how they may write things, which is influenced by their native language. So in this Indophony project, what we have been doing is to build again that robustness into our both query processing systems as well as our speech recognition, automatic speech recognition systems. So given, let's say, a base word in English, we are using these ideas from Indophony to synthetically create a lot of different phonetic variants of that word, and then using text to speech, create those different ways of speaking that word which actually mimics different accents that people may have, and trying to make our speech recognition systems understand all of those variants. So now, given, let's say, a base word, we are able to generate again and train our systems to work with many, many different variants of those words. And we find that many such variants do actually arise in real search queries that people are making. Another aspect of this access to when people are accessing information is people are often mixing up. So people who are bilingual or multilingual are often not sticking to one language, but mixing up words from different languages. So for instance, in India, it is very common for, let's say, a native Hindi speaker like me not to use pure Hindi in my queries or in my conversations, but use a mixture of Hindi and English. So what one needs to, so we can't just think in terms of only models for, let's say, English or a model for Hindi. You need multilingual models which are able to understand all of these kind of combinations as well. So again, our team has been building these multilingual models, language models, and one of the benefits of building such models is that we are able to on various natural language processing tasks, like named entity recognition, where kind of you need to, let's say, given the sentence, you have to identify, is there a person, place, or thing, right? So in this particular word sentence, Karan bahut khush hai, which is saying Karan is very happy, you have to identify the person, the entity, Karan over here, or on tasks like sentiment analysis, where you have to identify the sentiment. So this particular sentence, that Karan is very happy, has this positive sentiment. And as we build these multilingual models, what one benefit we get is that some of this learning on these tasks like named entity recognition or sentiment analysis, some of the languages with fewer resources, we are able to get the benefit of some of the learning that happens from languages with more resources like English or like Hindi, so that languages like Bengali or, let's say, Telugu, which have fewer resources, they are still able to benefit from some of that learning that happens. And so through this, we have built what we call Mural, multilingual representations for Indian languages, which provides the largest coverage to date for Indian languages. It covers 16 languages and English. And what we have shown is that on a variety of natural language processing tasks, things like named entity recognition or sentiment analysis or question and answering, we find that now by using Mural, we are able to get significant improvement in the performance on those various natural language processing tasks like answering questions. And we find the benefits to be even greater for transliterated text. So let me now switch gears, talk about some work we are doing to apply AI to health, which remains a huge problem for the entire world. And what we find is in countries like India, we find often additional challenges. And one challenge is that before you are able to do any AI on these health records, you first need to digitize those health records. And in a country like India, it is very common, except for large hospitals, when you go to a typical clinic, often the doctors are writing their prescriptions by hand on a piece of paper. So the question we asked was, how can you create an electronic health record out of that paper-based prescription? And it's a fairly non-trivial problem. because again, I mean, even if you apply, so what we did was we applied some of the state-of-the-art OCR, optical character recognition, and handwriting recognition techniques. And we tried to see if the system could automatically, from such a medical, let's say, prescription write-up, if you could automatically infer the medicines that have been prescribed. And we found the accuracy rates to be quite low, of the order of 10 to 11%, even when using state-of-the-art techniques for OCR and handwriting recognition. So and what is needed first here is often you first need to, given, let's say, such a prescription, you need to first do the right kind of, identify the right regions, cluster them appropriately, which correspond to different kinds of entries being made. So for instance, here, this doctor has used this region to record the body vitals. This region has various observations. This region has various lab results. And this region has the medicine names. So the challenge before an AI system is to figure these things out automatically, and kind of and do that, right, for different kinds of styles that different doctors may have of how they write prescriptions. But what you're trying to exploit is there's an underlying method to the madness, that there are certain kind of typical ways in which prescriptions are written, which need not be the same across doctors. But when, for instance, that you have, let's say, medicines which are being prescribed, you would have the name of the medicine, the number of days for which it is to be taken, the frequency, is it to be taken, let's say, twice a day or 3 times a day, and so on, and potentially some instructions for how to take that medicine, and so on. So here we are again applying a combination of vision, natural language processing techniques, and medical domain understanding, right, to make a to be able to accurately capture this information and recreate electronic health records. We've also been, as part of our formal AI for Social Good program, we've been working with nonprofits to bring the benefits of AI again to the not so privileged sections of the society, and have them benefit from technologies like AI. So one of the NGOs we are working with is Arman, whose mission is to improve maternal and child health. And some of the statistics that Arman shared with us were very sobering. That in India, a woman dies during childbirth every 15 minutes. And there are, again, a very large number of children who die under the age of 5 due to malnourishment. So Arman has this program where they enroll these expecting mothers into this program called Amitra. And what they do for all of these expecting mothers is they send out these automated messages via voice calls during the pregnancy period, and then after the child is born for the first year of the child's life, to share helpful tips about what to do, let's say, during this particular week. Whether, let's say, the expecting mother, she should be taking iron tablets to reduce the risk of anemia, or after the child is born, let's say, getting them certain vaccinations. Now, one of the problems that Arman has faced is that although they've seen some really amazing outcomes, improvements in the health outcomes for women who stay throughout this program, they find almost 40% of the women end up dropping out of that program for various reasons. So they asked us to see if we could apply AI to help identify who were those women who were likely to drop out, and figure out a way of engaging them. And in fact, Armand does have various human volunteers, but these human volunteers are only able to cover a very, very small subset of women who are enrolled in that program, because at a given time, they may have, let's say, of the order of 25,000 women who are enrolled, and they may only be able to reach out through their human volunteers to maybe of the order of, let's say, 500 women. So the problem we asked was, okay, if you were only able to reach out to a very small number of the beneficiaries, who are the high priority beneficiaries, right, that you should reach out to? And we, again, our team posed this as a restless multi-armed bandits problem, where the original statement of the problem was, let's say, in a casino setting, kind of which arms to pull, right, to maximize your records, maximize your rewards. And here, the corresponding analog is that given all of these, again, beneficiaries, like the analog of which arms to pull is which are those women who are otherwise likely to drop out, who should be engaged through a human volunteer who can explain to them the benefits of staying with that program and hopefully keep them engaged. So this is like a classical, again, restless multi-armed bandits problem, where typically, I mean, what you need to do is you need to model these transitions that may that take, let's say, a person from a good state, which is engaged, to a bad state, or vice versa. And over here, I mean, normally you solve it by kind of, you typically know those different transition probabilities. In case of this particular setting, we did not know those prior probabilities ahead of time. So we used historical data to cluster those beneficiaries, and we start estimating some of these parameters from analysis of historical data. But again, I mean, as we using these techniques, as we identified, okay, the subset of those beneficiaries that should receive a call from the human volunteer, we decided to test that in a randomized clinical control trial. And in the study with 23,000 beneficiaries, where the control group kind of had engagement through in a round robin fashion, whereas in this group, which we were, again, where we were applying AI techniques, and we identify, okay, which women were at a high risk of dropping out and potentially could be kept engaged by a conversation, through that conversation with a human volunteer. Through that, we were able to get significant improvements in the engagement. So over 30% improvement in the engagement of women. And through prior studies, we know that that is going to result in positive outcomes. But we are now in the process of launching a bigger study where we hope to show end-to-end, again, as a result of AI directly, the impact in terms of number of lives we are able to save, as well as improved health of children. Finally, in an area we've been also working on applying AI techniques to the area of wildlife conservation. We are working with this nonprofit called Wildlife Conservation Trust in partnership with our academic partners from Singapore Management University. The problem we are looking at is in a country like India, many of these forest areas are not like entirely protected areas. They are multi-use. And so there are humans and animals that are co-inhabiting shared spaces, which creates that potential for human-wildlife conflict. So the problem that was posed to us is, can you predict some of those conflicts, right, for the future by analyzing past data? And one of the issues is that data tends to be very, very sparse. But again, we have applied techniques by breaking down those regions into zones and looking at both kind of historical data that we have, as well as satellite imagery data that gives us insights about, again, the population density, the amount of wildlife, the amount of vegetation that's there, and so on. We've been predicting the conflicts that might happen in future in each zone, and we've been able to get some pretty significant kind of, as we have tested it on historical data, we've been able to get some pretty significant improvements in the accuracy. So we are in the process of working again with that nonprofit Wildlife Conservation Trust and the government of Maharashtra to be able to then send appropriate warnings. And the goal is to reduce the human-wildlife conflict and therefore, again, keep space for animals, avoid kind of animals being killed and so on without any loss of human lives, right? Without any damage caused to humans. So I've given kind of a peek at at problems from different domains that we are looking at tackling through the use of AI. But what I've shared is just the tip of the iceberg. Today, there are just amazing, fascinating opportunities in many, many different areas, including like education, agriculture, and so on, to apply AI to real world problems and make a difference. And we look forward to, again, expanding our work with more of nonprofits to bring the benefits of AI to various communities. And with this, in fact, we have significantly expanded our AI for Social Good program to launch 30 new projects this year, covering India, Southeast Asia, and Africa in the areas of public health, wildlife conservation, and agriculture.
Thank you, Dr. Manish Gupta.